solving using square roots. So all this stuff with factoring was simply one method for solving quadratic equations. Okay, we're going to start to get into now more methods for solving quadratic equations. The problem with factoring is it has to be a factorable quadratic. Okay, if we got one and we did our cross and we end up with, say, 13 and 7 in the bottom, well, there's no two numbers that can multiply to get 13 that have to be 7. Okay, so this is one that would be not to be factorable. If we ended up with a cross that we couldn't come up with the two numbers, it's not possible. So we need another strategy then. If it's not factorable, what else can we do? And we're going to start covering more strategies on what we can do. So one we're going to talk about today is called solving using square roots. Okay, so we can solve any equation that contains a perfect square by finding square roots. Okay, as long as we have this perfect square going on, we can undo the squaring using square roots. Okay, and what we're going to get into is this form ax squared equals c. All right, so this is still working with the same standard form that we've been doing. I mean, we've been working with ax squared plus bx plus c, where c, again, is just some number. Okay, it could be 5, it could be -5. We're just saying c represents some number. But now our b is 0. Okay, so we just have ax squared and we have some number going on. Well, we can write it as ax squared equals some number. So in order to use square roots, it has to be in this form, ax squared equals some value c. If you have any b going on, if b is a number other than 0, you cannot solve using square roots. So let's jump right into one. If I wanted to solve 4x squared plus 10 equals 46. Okay, so this one, I want to get it in that form, ax squared equaling some value for c. I want to get it in that form. Well, I can get it to that form if I subtract 10 from each side, and then I have 4x squared equals 36. So just with moving the 10 around, I'm where I'm at ax squared equals some constant c, some number. Well, now it's 4x squared equals 36. How do I solve 4x squared equals 36? Can I solve that for x? Just like any solving, we want to isolate the x by itself. So I want to get rid of this 4 from the left, so I divide by 4, divide by 4. So x squared then will equal 9. And I'm solving using square roots. So that means if I take the square root of what I have here on the left, that leaves me with x, which is what I want. I'm trying to solve for x. But now I take the square root of this side and I get 3. But that is not a complete answer. Why? Is 3 my only solution? Yes or no? No. What could be the other solution to this? -3. Okay? So this could actually be plus or minus 3. So when we're undoing the squaring, we have to be thinking in our brains too, thinking logically about what is actually happening. Okay? And we can always check this. Okay? If I wanted to check, I could say, well, -3 squared, yep, that equals 9. But +3 squared, that equals 9 as well. So my final answer is plus or minus 3. Okay? Whenever you are undoing, and you can highlight this, star it, box it, whenever, whatever. Whenever you undo a square, you always add in that plus minus. Okay? Whenever you have something squared and you're undoing it using a square root, that immediately should populate plus minus when you're working through the problem. Okay? Because squaring, I can take a negative value, square it, or I can take a positive value, square it, and I get the same answer. Okay? So again, box that in, star it, whatever you got to do. Do not miss that plus minus, because if you miss that, you will lose points. Okay? Do not make that mistake. Okay, so the final answer for this one would be a -3 or a +3. Emma. No, you could say x equals -3, comma, +3. You could write it like that too. Plus, minus, this is a shorthand mathematical notation to represent both of them. Okay. All right, let's do another one. We have 3x squared minus 96 equals c. So you do this one. Tell me what you come up with. Okay, I'm going to jump in on this one even if you're not done yet, because I think we might be kind of hitting the same spot. So this one we'd have 3x squared equals now a positive 96. If we were to bring that over, divided by 3, divided by 3. So x squared equals 32. So then x would equal a plus minus root 32. And we get to this point. Okay, is everybody able to get to this point? All right. So now here in algebra 2, we're going to take this now a step further. Okay, square root of 32, if you try to do it in your calculator, it either gives you a decimal value or it leaves it as square root of 32. You can't take the square root of 32 because there's nothing you can square to get 32 as an answer. Okay, so this is why it stops you right here. What we are going to do is actually look at how...
At this time, if you could send freshmen.
So we can simplify root 32 into a product that has a perfect square in it. So we want to remove all perfect squares from inside the square root. Okay, so let's think of perfect squares. So perfect squares are numbers that when I square them, that becomes a perfect square. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 16, 5 squared, 25, and we could keep going. So 1, 4, 9, 16, 25, those are all perfect squares. We want to use those. Those are our friends, okay? Whenever we're trying to break up something under a square root, those are the numbers we're looking for to see if they are a factor. 1, 4, 9, 16, 36, 49, 64, 81, and we can keep going. And all it's found is taking 1, 2, 3, 4, 5 and keep going and just squaring those. Okay, so 32. I want a perfect square to be a factor. Okay, and I want the largest perfect square to be a factor. Well, I know I can do 1 and 32, but that doesn't really help me. I mean, 1 is a perfect square, but I want to find that largest perfect square. I could do 2 and 16. 2 times 16 is 32. This pops right out. This 16 is a nice perfect square, and that's a big perfect square. I can't go any bigger than 16 because then I jump to 25. 25 is not a factor of 32. So what I can do now, my root 32, I can break this up into, say, that is 2 times 16, all under a radical. All right, that means the same thing. Square root of 32 is the same thing as the square root of 2 times 16. But now with square roots, I can completely separate these and say this is square root of 2 times square root of 16. And the whole reason I'm doing this is because square root of 16 now becomes 4. So I've eliminated that square root symbol from the 16. Square root of 2 stays as square root of 2. There's nothing I can do with that. So my final answer here would be 4 root 2. Okay, we always write the number, and then if there's any square roots, we write that after the number. Just like if I had an x and a 4, I'd write it as 4x. I wouldn't write it as x4. So we write it as 4 root 2. So square root of 32 is the same thing as 4 root 2. And getting it to that step of 4 root 2 is what I'm going to expect from you. Okay? So any of these that we can simplify, we can continue to work them down. All right, so going back to this problem right here, where we ended up with plus minus root 32, I actually want to see this as plus minus 4 root 2 as a final answer. If you stop at plus minus root 32, you're going to lose points. Ben. So it's just like this, plus minus 4, and these are being multiplied, so it's plus minus 4 times root 2. So just like that. Nope, it will still be plus minus 4 root 2. So you could have, if you thought of it on a coordinate axis, you could have over here at negative 4 root 2 and over here at a positive 4 root 2. No, 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 you got to include that. Okay. All right, so you do. So this one we're going to simplify. Square root of 216, and I'm telling you that this will break up into a product of 2 radicals with one being a perfect square. Okay, so again, we should be looking for perfect squares as a factor. So 1 you can pretty much ignore because 1 doesn't do any good. So again, you're looking, is there a 4 that's a factor? Is there a 9? Is there a 16? Is there a 25? 36, 49, 64, 81. So you're looking to see those specific ones. Are those a factor? So you don't have to test all numbers. You're only testing perfect squares. So what is my largest perfect square that is a factor of 216? What is it? 36. Okay, what times 36? 6. So 6 times 36 is equivalent to 216. But now the benefit of this is I can break this up into root 6 and then root 36. This one we simplify to become just 6. We still have our root 6. And so now my final answer would be 6 root 6. All right, so square root of 216 in simplified form is 6 root 6. All right, so again, all you have to test are those perfect squares. Find the largest one that is a factor, break it out, and then simplify. Okay, last one. So solve this. So now tell me that value of x and make sure your final answer is in simplified form. Okay, so this would be, oops. So this would be 5x squared equals 40. So if we divide by 5, x squared would equal to 8. So then x would equal plus minus 8. Well, plus minus 8, we can break up as to 2 times 4, all under the radical still. We can break these apart, and root 2 times root 4. So this becomes plus minus root 2, which stays, times 2. So then final answer, x has to be plus minus 2 root 2. Okay, so make sure you keep those under the radical, and then you can do your separation, break them apart. 4 was our only perfect square going into 8. So 2 root 2, not square root of 8. It is 2 root 2. And again, that plus minus, do not forget the plus minus. Okay? All right, so assignment, real quick one. Only a few problems. 237, 12 through 17.